Hello there guys, and welcome back to another video. This is still graphing quadratics, but it is, where should we do it? It's number 2, okay? It's number 2, it's part 2, all right? Right, in this video, we're looking at the same problem that we were in the previous one, 2x squared plus 7x minus 15 equals y equals whatever way around you want to say it. But there's something that we haven't done yet. We haven't looked at completing the square and the applications of completing the square into helping us to sketch things. So we've got the same notes as we did beforehand, but I've cramped it even more by putting more notes. This is actually just one note. This one note says completing the square can tell you the highest / lowest point on the curve. These are called maxima and minima respectively, okay? So, for instance, we want to find this point here on this particular quadratic. Is that a maxima or a minima? That's a minima because it's at the bottom. There isn't a maxima on this curve because this will just go up and up and up forever, and this will go up and up and up forever. There isn't going to be another point where like it does like a sort of dip and you can find the top, right? It's like trying to find the top of a hill or the bottom of a valley. We've got the bottom of a valley on this one. On another one that is shaped like this, yes, you can find the top of a hill. Maybe it's about there, something like that. Something to note is it's not usually, sometimes it can be, but it's not usually actually the same as the y-intercept. Some people might think it is. You might say, well, isn't the y-intercept the minimum? Not necessarily, no. Because the curve can go to the side of the y-intercept. So, if you were to hypothetically just have something x squared plus, well, we'll say it this way. If y was equal to ax squared plus c, then yes. Yes, c would be the maxima or minima, depending on whether or not a is positive or negative. That's correct. But this here, this bx term, is causing the graph to go to the side, so you can't actually always say it's the y-intercept. So don't assume the maximum or minimum are y-intercepts, because they can be, but it's really not usual, okay? If there's a b term, it's not going to be. Okay, so how on earth do you use completing the square to figure out what these maximum and minimum are? I'm going to show you something. Let's do it. Let's complete the square on this to start with. Let's just do that. How do we complete the square? Okay, we're going to factor out the 2, I would say. So we're going to go y is equal to 2 times x squared plus 7 over 2x minus 15 over 2. I feel a calculator coming on, to be honest, guys. So that's going to be 2x plus 7 over 4 squared. Again, you should know how to do this. Okay, and I'm going to use a calculator because even though I don't know how to do that. Okay, so we're just going to sort of figure this out. So we've got the 2 here, we've got this here, this here, this here. We are going to say that we still need to take away, we actually need another bracket there. We still need to take away 15 over 2. That's fine. Y equals 2 times x plus 7 over 4 squared. And we also need to take away that. So it's minus 15 over 2 minus 7 over 4 in actuality, okay? Or rather 7 squared over 4 squared. So if we do that, we have got 15 over 2, taking that away, minus 15 over 2, minus, that's going to be 49 over 16. We get y equals 2 times x plus 7 over 4 squared minus 169 over 16, which means that y equals 2 times x plus 7 over 4 squared minus 169 over 8. We just distributed this 2 out. That's it. Okay, so what's going on here, guys? What's happened? We've completed the square. Something else has happened though, something very important. Here is a property of completing the square. You might not realise it, you might not see it, but actually we are very near to being able to find the minimum x's and y points on this curve. Let's tell you. Okay, now just think about it intuitively, right? Looking at this, this is what we're talking about. If x was minus 7 over 4, minus 7 over 4 plus 7 over 4 is 0. So this is 2 lots of 0 squared, that's just 0, forget about it, that whole term just disappears, minus 169 over 8. If x was anything but minus 7 over 4, this bracket would actually turn positive, because even if you chose a value of x that could make this bracket negative, squaring it would make it positive. So you actually have, in every case, the minimum x value is always the negative of what's being added inside that squared bracket. So we know we're trying to find the coordinates of the minimum. We know the x coordinate is minus 7 over 4, which, I mean, guys, look at it. That looks right, because minus 7 over 4 is just a little bit to the left. That looks about legit, right? Okay, why have I put a bracket there? Who knows? The y coordinate is simply what you get left over with, because y equals 0 minus 169 over 8. What's 0 minus 169 over 8, guys? It's minus 169 over 8. So y equals minus 169 over 8. So, in other words, this point has got the coordinates minus 7 over 4 minus 169 over 8. That point there has got that point. So, you use completing the square to do this. Brilliant. Let's do one more example, make sure we definitely understand, but that's generally the principle behind it. Okay guys, let's check out the quadratic that I use all the time, and you'll probably be seeing more and more and more of it throughout this course. It's the quadratic y equals x squared minus 2x plus 1. We should be able to look at this by now and clearly tell what the solutions are when y is 0. When y is 0, we have got 0 equals x squared minus 2x plus 1. What x values do we put in here? Think about it, guys. What squared minus 2 lots of that number plus 1 equals 0? Well, that number is going to be the number 1. Positive 1. 1 squared minus 2 times 1. 1 minus 2, that is. Plus 1, yes, that's 0. 1 minus 2 is minus 1. Add 1, yes, you do have 0. So without even solving it, because we've done it many times, x equals 1. That's it. There's only one solution, okay? So we're going to plot it. X equals 1, that's it. So it's going to look like that, okay? So this is the graph, I'll do it over here. Y equals x squared minus 2x plus 1. Just make sure you always label your axes, guys. I just didn't do that. That's a 0. So to notice is, if you've only got one solution to your quadratic at y equals 0, how many times is the graph going to touch the x-axis? Once. If you get two solutions, like in the previous one, it's going to touch it twice. Now, you can get no solutions as well, and we'll talk about that, and we'll talk about why that is. But if you get no solutions, the graph will not touch the x-axis. So the number of times that the graph touches the x-axis is the number of solutions that you'll get to the problem. Whatever your function is, ax squared plus bx plus c equals 0. It's always the solution to that, the x values that satisfy that. Okay, so it just skims at 1, 0. It just touches it. Doesn't go below, it just touches it, just tangentially sort of like, yeah, like it really just sort of skims it, doesn't do anything else, doesn't go through it. Otherwise there'd be two solutions. Okay, so that means you know, again, what is it? Is it a maxima or a minima, guys? It's a minima, isn't it? It's a minima because it's at the bottom, it's like the bottom of a valley, okay? So guys, you actually can tell what the minima is because the minima is actually clearly at this coordinate, isn't it? It's right there, you can see it. That's the minima, it's that point. That's why I chose it. So we're going to show you that completing the square method always works, okay? So let's complete the square on this function x squared minus 2x plus 1. Let's complete the square on it. Okay, so we're going to complete the square. Again, we should know how to do this. So that gives you, so then that's it, right? Yeah, it's a perfect square. So that is actually the completed the square version, and that's equal to y. Boom. Now, if you don't believe me, you can expand that out. You get x squared minus 2x plus 1. Perfect. It's a perfect square. It's already kind of complete in a way. So how do we do it? We say, let's set it equal to, or no, we don't even need to set it equal to. Let's say y equals x minus 1 squared. Okay, think about it. Right. How do you make that bracket go to 0? Or how do you minimize the bracket? You want the bracket to be 0, right? The bracket is 0. What does x have to be? X has to be 1. So our coordinate is 1 something. When x is 1, what's y? Well, that's 0. So y is 0. So y, guys, y, 0. That's the minimum. 1, 0. 1, 0. Magic. That's a really easy question because it's already a perfect square. But if we had something else, I don't know, let's say it was, instead of plus 1, let's say it was plus 5. Whatever. I don't know how neat this is going to be. We won't work out the x coordinates because that's not really relevant, but let's actually complete the square on it. So I'm going to sort of rub this bit off because we don't need it. Let's just complete the square on this. And let's only, we don't want like the x-intercept, we just want the minimum point. Okay, let's do it. So let's complete the square. This is going to be still x minus 1 squared minus 1 plus 5, because we need to take the 1 away that comes back. So we get x minus 1 squared plus 4, that's equal to y. So y equals x minus 1 squared plus 4. Yeah, we agree? I hope we agree. How do you minimize that square bracket? Again, you want it to equal 0. What value for x satisfies that? When x is 1. 1. Okay. When x is 1 and this bracket is 0, what is y? Well, y is 0 plus 4. 1, 4. So this graph, again, I don't know what it looks like, but it's going to have, again, that's an x-axis, that's a y-axis, that's 0. It is going to have a minimum point at 1, 4, so it's going to look something like that. Again, I just totally ignored that. That point there would be 1, 4. You can clearly see that graph has no solutions because it doesn't cross the x-axis, and we can tell just by completing the square that it doesn't cross the x-axis. I mean, look at it. It's never going to cross the x-axis, is it? So we can immediately tell it has no solutions, which means if a graph is shaped like that, there are no numbers that you can ever put in where x are to make this equal 0. So there is no number that is real, there is no real number, such that that number squared minus 2 lots of it plus 5 equals 0. That number, as long as we're just talking about real numbers, guys, that number doesn't exist. So that's quite interesting, and that happens a lot. In the next video, we're going to talk about the discriminant and why you actually get things like this happening. So guys, I hope you enjoyed the video. If you want me to make more of this stuff, please tell me. This is a bit of a challenging one to teach. It's all new. Trying to do quadratic graphs without even doing straight line graphs, it's a bit of a challenge, I know. If you want to see more videos, I'm happy to make them. Please give me feedback. Feedback, I don't care whether it's positive, negative, or anything in the middle. Tell me, give me feedback. Anyways guys, thanks for watching. I'll see you guys in the next one.